All right, welcome back to the deep dive. Today, we're going to be looking at the last steps, like the really crucial final steps of making purified bioproducts.
Mm-hmm.
And, we've talked about all the upstream stuff and, getting it right in the middle.
Right.
And now we're talking about the final presentation. Kind of like, when you go to a fancy restaurant and you get that nice dessert at the end. This is the dessert, right?
Absolutely. Yeah.
So we're talking drying and crystallization.
Yeah.
And these might not at first sound like super exciting
Right.
steps, but they are super important for stability, preservation, and, making sure that product is really, really pure.
Exactly.
We've got a great note here with us today, going over, all the principles and all the different techniques for drying and crystallization and downstream processing.
Yeah.
And our mission today is to kind of distill it all down into the good stuff. To
Absolutely.
get rid of the fluff, get rid of the boring parts, just get to the good stuff so you can actually use this.
Exactly. You don't want to get bogged down in all the details, right? You want just the good stuff, just the meat of it.
Exactly. Just the meat
Yeah.
and potatoes.
Perfect analogy. Yeah.
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 So let's just dive right into drying, I guess. What do you think?
Yeah. Let's get into it. Let's dry it out.
Yeah. So the fundamental idea behind drying, right, is basically just removing water or any solvents, really to
Yeah.
make this nice, stable solid.
Yeah.
And that's super important because, like I was saying earlier, it helps prevent it from degrading. It makes it last longer on the shelf.
Right.
And it just makes it way easier to ship around.
Exactly. Less volume to deal with.
Exactly. Less volume makes everything easier. So, probably the simplest way to dry something is just air drying.
Yeah.
Just letting the water evaporate naturally.
Just leave it out in the open air. Let it dry. The thing about that is it can be kind of slow and unpredictable. It really depends on the environment.
Right.
So it's not the most reliable.
Yeah. And if you're, a company that's trying to, produce and sell this stuff.
Right, on a large scale.
Yeah, you need it to be a little more predictable and a little more consistent.
Yeah.
So that's where things like oven drying come in, right? Or tray drying.
Exactly. Yeah, it's a bit more controlled. Oven drying or tray drying, it uses heat and airflow
Yeah.
that we can actually control to speed things up a bit.
Right, exactly.
Yeah.
And now, what if we need to go even faster and more consistent?
Well, if you need it even faster and more consistent, you might want to look into something called fluidized bed drying. So think of it this way. You got these tiny little particles of your product.
Okay.
You suspend them in a stream of hot air.
Like a wind tunnel kind of thing.
Kind of, yeah. It dries them super fast, and it ensures that every single particle is dried evenly.
Okay. Wow.
Yeah. And then there's another method, spray drying, which I think is particularly cool.
Okay, what is that?
So in spray drying, you basically atomize a liquid. You turn it into a super fine mist, and then you hit it with a really hot gas and almost instantaneously
Right.
get a powder.
That's crazy.
Yeah, it's pretty cool.
Liquid to powder, just like that.
Exactly. And what's even cooler is you can even control the shape of the particles by changing the conditions of the spray drying process.
Oh.
Yeah, so if you need a powder with specific property,
Right, okay.
spray drying can be a really good option.
Wow, that's super cool. So we've got all these different methods, right? We've got like the simple air drying all the way to the super high-tech
Yeah,
spray drying.
exactly. But what about the really sensitive stuff, right?
Yeah, like what if you have a product that's like super delicate?
Right. If it's really sensitive to heat,
Exactly.
you need something really gentle.
Yeah.
And for that, we have freeze drying or lyophilization,
Okay.
which is the most gentle method we have. So how it works is you freeze the product
Okay.
and then you reduce the pressure and the ice in the product turns directly into vapor.
Oh, wow.
It skips the liquid phase entirely.
Wow. Is that like sublimation or something?
Yeah, exactly. It's sublimation.
Okay, so basically instead of going from ice to water to vapor,
Yeah.
it goes straight from ice to vapor.
Exactly. And because you're not using high heat, it preserves the integrity of the product really, really well.
Oh, okay, that's super cool. I'm learning a lot today. This is really good stuff.
It's pretty amazing the different techniques we have.
Yeah. So far we've covered, getting all the liquids out.
Right.
But now we got to crystallize our understanding of crystallization.
I see what you did there.
Yeah, so what's the core principle behind crystallization?
So crystallization is all about forming pure, solid crystals from a solution or a melt. And the driving force behind all of this is something called supersaturation.
Supersaturation. Okay, break that down for me a little bit.
Okay, so imagine you're making a cup of tea.
So,
You add sugar to your tea, and you keep adding sugar. And
It's
eventually,
too sweet.
well, before it gets too sweet, the tea can't hold any more sugar.
Right.
So what happens? The sugar starts to form crystals.
oh,
Supersaturation is like that too much state for our bioproduct. We create conditions where the solution just can't hold it anymore.
okay.
And it starts forming these beautiful, ordered structures, crystals. And the great thing about crystals is they tend to be very pure.
Okay, so that's why we're doing all this.
Yeah.
Because crystals are pure.
Exactly. High purity is the goal.
Okay, so how do we actually achieve that supersaturation? Like, how do we get to that state where it just can't hold anymore?
So there are several ways. One way is cooling crystallization, where you reduce the solubility of the product by lowering the temperature.
Okay, so it's like as it gets colder, it can't hold as much.
Exactly. And then there's evaporative crystallization, where you concentrate the solution by removing the solvent.
Okay, so you're just basically, boiling off the water or whatever the solvent
Yes,
is.
essentially.
Got
And
it.
then there's reaction crystallization, where you use chemical changes, like altering the pH, to basically force the product out of solution. And it comes out as crystals. And then there's a really cool trick called seeding crystallization.
Oh, seeding. Okay, tell me about this.
So in seeding crystallization, you introduce tiny seed crystals into the solution.
Okay.
And these seed crystals act as templates for the growth of larger, more uniform crystals.
Oh, so it's like you give it a starting point.
Exactly. It's like giving it a blueprint to follow.
Okay, that's fascinating. So it's not just a matter of, throwing it into a beaker and waiting for it to happen.
No, not at all.
We're actually controlling this process really carefully.
Absolutely. Both drying and crystallization require really tight control over a bunch of different parameters.
Okay, like what kind of parameters are we talking about here?
So for drying, you're looking at things like temperature, pressure, airflow, humidity,
Okay.
especially if you're doing something like freeze drying,
Right.
which relies on vacuum. And then for crystallization, you're controlling temperature, mixing, the degree of supersaturation, and whether or not you're using seeding. And of course, time is a factor in both.
Right, of course. And while all this is happening, we're making sure that the product is good, right?
Oh, absolutely. Quality control is paramount. So for drying, you're constantly checking the moisture content, making sure it's at the right level. And for crystallization, you're looking at the crystal size, the shape, and the purity.
So what you're saying is these, seemingly simple steps
Right.
of drying and crystallization are actually way more complicated than
Yeah.
they seem on the surface.
A lot more goes into it than you might think.
Yeah.
You have to carefully select the right technique based on the specific bioproduct.
Right.
You got to consider its characteristics, the quality you're aiming for, how much of it you need to produce,
Yeah.
and even things like cost.
Right, economics. So it sounds like different products are going to need very different approaches in these final steps.
Exactly. And that's what makes this so fascinating, right?
Yeah.
These seemingly basic steps are actually deeply connected to the very nature of the bioproduct itself.
Yeah, that's a really good point. It's not just, one size fits all. It's all very specific.
Absolutely. And it all comes down to understanding the science behind it.
So for our listeners out there,
Yeah.
what should they be thinking about? Like, what's the takeaway here?
Well, I think the biggest takeaway is that drying and crystallization are these vital final steps in producing stable and pure bioproducts. And there's this whole toolkit of different techniques available, each with its own principles and parameters that need to be carefully controlled.
Exactly. So, we talked about freeze drying being really good for delicate products,
Yeah.
but it can be expensive.
Mm-hmm.
So I guess like a question our listeners could think about is, what else might make someone choose one of these, maybe more expensive
Right.
or more complicated techniques?
Yeah. What other factors are at play?
Besides just trying to prevent it from degrading,
Mm-hmm.
maybe they need it to be a powder, or maybe they need it to have these big crystals, or maybe it needs to stay stable for a really long time.
Right. Or maybe it needs to look a certain way for the consumer.
Yeah, exactly.
Yeah.
So it's not just about the science, it's about the practicality of it all too.
Absolutely.
So it's really fascinating to think about all the different factors that go into
Yeah.
these seemingly straightforward processes.
It really is.
So I think that about wraps it up for today.
Yeah, I think we covered it all.
We did a deep dive into drying and crystallization.
A very deep dive.
So thanks for joining us on the deep dive.
And we'll see you next time.
All right, see ya.